How should I hide this?
Is
it? Okay. Yeah. Okay. Okay. Hi, everyone. My name is Abdullah Al-Sherefi, and in today's presentation, I'm going to discuss fraud detection using supervised machine learning. So the objectives of this presentation, first, I'd like to introduce the topic of fraud, and especially in the banking sector, because it can happen in many industries, but our focus today will be only on the banking sector. I'd like to discuss about its impact on banks as well as its customers. And I would briefly discuss the current applied methods of fraud prevention and how machine learning can be used to combat fraud in general. So when we talk about fraud, as I said, it can be applied in any industry, but when we talk about fraud in banks, we are talking about unauthorized transactions that are happening on customers' accounts. These transactions can happen rapidly, so there has to be a way of monitoring these transactions and taking actions immediately once they happen. So why it's necessary for banks to prevent fraud or detect fraud in general? As I said, fraudulent banking transactions, they happen on a daily basis and sometimes at a very large scale that can impact the reputation of the bank as a secured bank. When a large-scale fraud happens on one of the merchants and many of the customers of one bank gets affected by that kind of attack, most of these customers will try to find a better bank that has like more security features. There are other ways, there are several ways for fraudsters to steal the card's information of the customers. So one of them is phishing, and this is we are actually encountering on a daily basis right now. So suddenly you would get a call that you won 20,000, 10,000 KD, so give us your card details. But there are also other methods. So for example, if you are using your card in a machine, like an ATM machine, and it didn't work, the transaction wasn't completed, but the next day you would find that there is a transaction that happened on your card. What happened at that time is that when you entered your card in the ATM machine, there was actually another device that was implanted by one of the fraudsters, so it captures all the card's details that are being entered into. But there are also other methods. As I said, the impact can be catastrophic, especially if it's on a large scale. And for customers, the downside or the most problematic thing is that when a fraud happens, the process of retrieving the money can take actually months to happen. So the customer is left without money all this time. So the problem that we have is that traditional banks, I don't want to say all banks, but like most banks, at least in Kuwait or in the region, when they are monitoring transactions, they are monitoring them using rule-based systems. What I mean by rule-based systems is that there are a set of rules that are applied in the system that run through every single transaction that happens. And if one of the transactions matches the criteria of these rules, then the transaction either gets highlighted for a fraud monitoring officer to call the customer, or it actually gets declined. One example for like one of the rules that can be set up in the system, if you do a transaction in Kuwait, a face-to-face transaction using a POS machine, and after 1 hour, there is another transaction that happened in the US, also using the same card. That can be impossible for a customer to travel from Kuwait to another country within 1 hour. That can be hard. So this rule will trigger the transaction, and then the customer needs to be contacted to make sure if there is any issue, so that they can cancel the card and start what's after the fraud process. Now, one of the downsides of having rule-based systems is that these rules can be exploited. For example, if you do a transaction 25 KD, for example. Here in Kuwait, you need to get an OTP for you to verify the transaction. But some fraudsters will try to use smaller amounts in bulk. So instead of doing one transaction that is above 25 KD, they will use 10 KD, 10 KD multiple times to reach to what they want. So the proposed solution, what do we have, or like what can we do? We can build a supervised machine learning model to classify transactions as fraudulent or non-fraudulent. And what I mean by supervised machine learning is that this machine learning will be fed the data, transactions, whether they were fraudulent or not fraudulent, but they will also have the labels of each transaction. So if the transaction is fraudulent, it will appear as fraudulent, and if not, then it will be non-fraudulent. The beauty about using supervised machine learning is that unconventional methods, we're not going to hard code every single rule. So it dynamically adapts. The more the model, the machine learning model trains on the transactions that you are feeding, the better it would be performing. So there is an example. It's a competition that was in 2019. It started by the IEEE CIS, and the objective of this competition was to predict the probability that an online transaction is fraudulent or not. The data set was provided by Vesta Corporation, and it contains real-world e-commerce transactions. The data structure of this competition, the data set has two tables. One table, it has all the details of the transactions, while the other table has the identity of that transaction. So what I mean by the table of transactions, you will get details about date, time, what card was used, the email address, the details of the customer himself that made the transaction. But for the identity, we are talking about the IP that was used, the browser, and technical details about how the transaction was processed. After merging these two tables, this is the final table that we have. So as you see, or like, let's go to the next slide. There are limitations with this table. Okay, sure. So there are limitations with this table. Most of the columns that you can see here, like from here till there, they don't represent anything. It's really hard to identify which field means what. And actually that was intentional by the competition, by the competition makers, because these data are really sensitive. And one other limitation that this data set has is that the fraudulent transactions only constitute 3.5% of the entire transactions. So the data set is highly imbalanced. And one other limitation is that there were more than like 250 fields that have more than 20% missing values. So we needed to like find better ways for the model to train on actual values and not just null values. So the pre-processing steps that I did were first discard any column that has more than 20% missing values. I replaced the missing values with the remaining columns, with either the median if it's a numerical column, or the most frequent if it's a categorical column. I also did one hot encoding, which basically transforms the categories. So for example, if you have one column that has many email IDs, each email ID will be in a separate column, and then the values will be either 0 or 1 for that record, because for machine learning it doesn't understand other than digits, so it's zeros or ones. And finally, since we have a highly imbalanced data set, I used a technique. It's called synthetic minority oversampling technique, which basically replicates the fraudulent transactions, so they appear more. So we will have a balanced data set. I used a random forest model, and Abdulrahman already talked about decision trees briefly, how they work. But basically, a random forest is an ensemble of decision trees. So each decision tree will be training on a subset of the data, and the final outcome will come from the majority voting. So if one subset, one decision tree said it's a fraudulent transaction and the other is non-fraudulent, the majority voting, that's what will be considered. The results, actually, we got 0.89. So this means that about 89% of the transactions were correctly labeled, which is a good number for such a challenging data set. And this curve here, this represents two things. So we have here the true positive rate and the false positive rate. So without getting into much technical details, the true positive rate, the more the model identifies these transactions, it will be leaning towards the true positive rate. But false positive rate, so if the model incorrectly labeled one of the transactions, it will be going on that side. And the area under the curve here, this means if it's larger, then the model is performing better. That's basically it. So I'll open if you need to ask any question. Okay. Sure. Sorry? Unfortunately not. Here in Kuwait, we have resistance against machine learning, and I understand the complications of that. Yeah, sorry, sure. Yeah, you need to ask questions.
How long before you had a supervised machine learning? How long did the rule sets change, or how frequent did they change?
Which rules exactly?
Yeah, the rules implemented to detect fraud.
See, when I spoke about rules are like, I'm talking about banks. What rules are applied in banks? When you talk about machine learning, there are no hard-coded rules. You don't need to to identify what rule can apply to that transaction to be labeled as fraud. The only thing that you would have is the label itself, if it's a fraudulent transaction or not. And based on the columns values, the machine learning would train, and it will capture the patterns from each record. So if more features indicate that the transaction is fraudulent and the label is fraudulent, then that's how it's going to generalize on data that it never seen before. Sure. No, I didn't actually. It was in 2019, and I lately got into machine learning. I'm not sure, honestly, but I think in the 90s, maybe 96, 97, in this range. Sure. Okay, so there are actually several reasons for that. One of them is that, as I said, for a bank to apply such model, it needs to carefully feed the data to the machine learning. If you if you have on the pipeline the data that you are retrieving, what transactions happened on the previous day, and then you are feeding it to the machine learning model, the problem would be that the machine learning model will only learn the patterns of the non-fraudulent transactions, because the number of fraudulent transactions will be really low. And that's the main thing. It needs constant maintenance. The data needs to be fed carefully. What I did in when I said about the pre-processing steps, one of them is the smooth technique. This technique inflates the numbers of the fraudulent transactions, but actually they do not exactly represent whether this actually transaction is fraudulent or not. I'm just making other copies of it based on how it's laid out on the grid.
So sure. Basically, this last step is to avoid overfitting the model.
Yeah, basically, because if you only have 3.5%, then any transaction that would happen would be recognized as non-fraudulent, because that's what it learned the most.
So regarding the rules that you mentioned for the transactions, so are these part of the core banking systems, or are these external systems that are managed?
See, for the banks, sure. For the banks, they have these systems, but they have the facility to apply the rules. So whenever there is any change in the fraud trends, they will update the rules manually. And that's one of the limitations that machine learning can actually overcome. One of the things that I mentioned is that, one example, if you do a transaction in Kuwait and after 1 hour you do a transaction outside Kuwait in any other country, this is logical. But actually, with the introduction of Apple Pay, you can set up your card in multiple devices, and you can give your device to one of your friends, and then they can transact on your card while you can do a transaction here. Both of these transactions is face-to-face. So for banks, if they do not update their rules, then many customers will have this issue.
I'll give you a unique case. A
Yeah.
friend of mine went to the military base in Kuwait.
Oh yeah, okay.
So that is considered a US.
Yes, right.
So he bought something from there.
Yes.
Then an hour later, he bought something in Kuwait. That instantly got flagged.
Yes, exactly. Okay. Yeah. Yeah, the POS machine that you have, the bank that provided this POS machine, it's from another country. So that's why the transaction is flagged that's coming from another country. Anyways, thank you so much, guys.